Today we're going to be talking about CoreLocation and MapKit frameworks and how to build map-based applications for the iPhone, iPod Touch, and iPad. So to build a map-based application, you need both the CoreLocation and MapKit. Both of these frameworks are available on the iPhone and the iPad, and the code you'll see during this presentation would work equally well on both platforms. Now later on, I'm actually going to do a live coding demo and go ahead and build a demonstration application for the iPhone. But I could just as easily build it for the iPad without changing very much code at all. So, CoreLocation and the GPS. CoreLocation framework is an abstraction of several different methods to find the user's location. It can provide the latitude, longitude, and altitude of the device, along with a level of accuracy to which these are known. Now, the actual method used to determine the user's location is abstracted away from both the user and you as a developer. So the only control you get over the chosen method is by requesting a certain level of accuracy. Although the actual accuracy you're going to get from the code is not actually guaranteed. Now, of course, some users may explicitly disable reporting their position. You should always check geo-location services are enabled before attempting to turn. So in order of resolution, the CoreLocation will first go and check cell towers, and you get a first approximate fix of about 12 kilometers, following to a much smaller fix of 1 to 2, depending on what sort of area. Then it'll go on to check Wi-Fi positioning if that's possible, and then if your device has a GPS, it will go down and use the GPS if possible. So, how exactly do you get this? Well, the heart of the CoreLocation framework is the CL-Location Manager class. Now here you can see we allocate and initialize an instance of the CL-Location Manager, set the delegate for that instance to self, the current class, and then we go off and check to see whether location services are enabled. And if they are, we actually start updating locations. And at that point, your class is going to receive delegate messages when the location of the device changes. Now, you should also bear in mind that if you're running your application in the simulator, for the release of the 4.0 SDK, the iPhone simulator always reported its location as being latitude plus 87.3 degrees, longitude minus 122 degrees, which corresponds to 1 infinite loop, Cupertino, California. These days, it'll actually ask you permission to get the location from your from macOS X itself. However, it's only going to work on Wi-Fi. So if you have Wi-Fi turned off in your laptop or your desktop machine, it's actually going to fail with an error, and it's not going to manage to get a location. There's also an annoying couple of bugs in the simulator to do with MapKit, which I'm going to talk about later during the live demo. So the location update messages I mentioned in the previous slides, we can actually filter these update messages based on distance. So changes of less than this amount will not generate an update message. Here, we've set the distance filter to be 1,000 meters. We can also set the desired level of accuracy. And as I said before, this is going to determine the location method or methods used by the framework to determine the user's location. Here we've asked for a location accuracy of 1 kilometer. So it's going to use cell location, Wi-Fi location, and then dropping down to GPS. So the CL-Location Manager Delegate protocol offers 2 methods. First is called when a location update occurs, and the second is called when an error occurs. So Location Manager did update to location from location is called when a new update message arrives at your delegate. And it's a good idea to check whether the new location is not equal to the old location, because that can happen sometimes. If a location manager is not able to ascertain the user's location immediately, it's going to report a KCL error location unknown error, and then keep trying to find the user's location. Now, in most cases, you can actually choose to ignore this error and wait for a new event. However, if the user has denied your application access to the location service, the manager is going to report a different error, KCL error denied error. Upon receiving this sort of error, you're just going to have to stop the location manager and give up, because you get a position from this. So the magnetometer, or the digital compass. I'm a physicist, so I generally call the sensor magnetometer. Now, the magnetometer measures the strength of the magnetic field surrounding the device. And in the absence of any strong local fields, these measurements will actually be the ambient magnetic field of the Earth, which allows it to act as a digital compass. For comparison, the Earth's magnetic field is about 0.6 Gauss, and the magnetometer on the iPhone will measure to about plus or minus 2 Gauss, or about 200 microteslas. The sensitivity less than about 100 microgauss. So you're going to get small changes in the magnetic field will actually. So the magnetometer measures the yaw or azimuth of the device. Now, combining the heading, yaw information returned by the device, the magnetometer, with the raw accelerometer, you're actually going to be able to determine the true location of the iPhone in real time. And in the iPhone 4, where there's a gyroscope available, this is, and 4 motion framework, it's even easier to do this. But that's an entirely different webcast. So how do you go ahead and use the magnetometer to get the heading? Pretty much exactly the same way as you use the location services to get the location. You just check to see whether the heading is available in your location manager instance, and then you start update heading, and this will call a separate set of delegate methods in your class. Now, it's even more important to check whether heading information is available than it is to check whether location services are available. The availability of heading information is currently restricted to the iPhone, 3GS, 4, and iPad devices only. And mentioning the iPad, it's only actually available in the Wi-Fi plus 3G model, as that's the only one with a GPS fitted. So if you just have a pure Wi-Fi iPad, you can't get heading information. In the same way as you could filter the location update messages, you can filter the heading update messages. Here we've filtered them on 5-degree increments. So if your heading changes by less than this amount, there won't be an update message sent to your delegate. And here is the delegate method. Location manager did update heading. Basically, you should check every time if the new heading accuracy is greater than 0 before processing any event. A heading accuracy of less than 0 indicates that the heading is bogus or hasn't calibrated correctly, or something else is going on that you pretty much ignore. So if location updates are also enabled, the location manager returns both the true heading and the magnetic heading values. And if location updates are not enabled, the location manager will only return the magnetic heading value. So this is the 2 different headings, the difference between true north and magnetic north. Now, interestingly, if location updates are not enabled, you can still use CoreLocation to get the magnetic heading from the device without the user being informed. Remember, if you ask for a location for the user, it'll always put a pop-up on the user screen to say that your application is requesting a location. But unlike a location, there isn't a pop-up here if location updates are not invoked. So if you're just asking for magnetic heading, the user will not be informed about this. Now, the magnetic and true headings are correct when the iPhone device is held like a traditional compass in portrait mode. If the user rotates the device, then the heading readings will still be in this frame of reference. And that means even though the user has not changed the direction they're facing, the heading values are reported by the device. So we're actually going to have to correct the orientation before reporting headings back to the user. We can use the device's accelerometer to determine the device orientation to do that. So you grab the orientation from the UI device object, and then you just use a switch statement and correct the magnetic heading returned, but magnetic or true heading returned by the device into a real heading based on the current orientation of the device. Pretty simple. And then, of course, you correct to make sure that you haven't actually accidentally moved the device's heading above 360. So the magnetometer readings will be affected by local magnetic fields. And the CL Location Manager is going to attempt to calibrate its headings readings by displaying a heading calibration panel before it starts to issue updates. However, before it does it, it's going to call this delegate method. And if you return yes from this method, the CL Location Manager will proceed to display the device calibration panel, which you've probably seen if you've used the inbuilt compass application. And the calibration panel is going to prompt the user to move the device in a figure-of-8 pattern so that CoreLocation can distinguish between the Earth's magnetic field and any ambient local fields. And that panel is going to remain visible until your calibration is complete, until you dismiss it explicitly by calling dismiss heading calibration panel method in your CL Location Manager class. If you don't calibrate, if you don't allow the calibration to be displayed by returning no from this method, the information you're going to get back is probably not. So that's CoreLocation. Let's talk about MapKit. Now, MapKit framework allows you to embed maps directly into your views and provides support for annotating these maps and performing reverse geocoding lookups to determine information for the given latitude and longitude of the view. So, how do we go about and do this? Well, you create a normal view controller. Here's just a really simple one, and create an instance of MKMapView instance variable and declare it as a property and an IB outlet. And you save that, and you drop into Interface Builder and drag and drop an MKMapView from the library window into the view window and connect it to the instance variable in Files Owner. If you hit build and go at that point, you're going to get something that looks like this, which is a map view and does display a map in your iPhone, but isn't terribly interesting. So let's look at delegate methods. If we want to move the map with the user, we actually have to use CoreLocation to do that. There are no hooks in MapKit to do. And this is the location manager did update to location from location delegate I discussed. Now, here we check to see whether the new location is not equal to the old location, and if it isn't, we go ahead and do this block of code. Now, what we're doing here is the number of miles spanned by degree of longitude varies based on the current latitude. So, for example, 1 degree of longitude spans a distance of approximately 69 miles at the equator, and that is going to shrink to 0 miles at the poles. But unlike longitudinal distances, which vary based on latitude, 1 degree of latitude is always going to be 69 miles, ignoring variations due to the slightly ellipsoidal shape of the Earth. So what we're doing here is we're getting that scale, and we're correcting the latitude, delta, and longitude, and that variation based on latitude rather, and then grabbing the coordinates from the new location, and we're setting the map view region in an animated way to be that region, a sort of a square region of about 2 miles square. And then we're going to show the user location. And that's going to produce something like that. So the user location is going to show up as by default as a blue dot, and you're going to get a roughly 2 mile square box around it. Okay, so annotations. If you want to add annotations to your map, you have to create an annotation object that implements the MKAnnotation protocol. Now, oddly enough, there's no actual default implementation of this protocol inside MapKit framework, so you have to roll your own. So this is a bare bones simple annotation object. We create a MKAnnotation. We create instance variables for coordinates, a title and subtitle, and we create a simple init with coordinate method. Here's the corresponding implementation where we just grab the coordinates from the init method and put them into the property, and then we release our title, subtitle. That's it. So it really is a very, very simple wrapper around the so how do we add annotations? Well, here we're going to create an instance of our simple annotation class, an initial set of coordinates. Then we grab a region around those coordinates and set the map view around that region, add the annotation to the map view, and then we just release our annotation. And that's going to give you something like that. So that's just us dropped an annotation on One Infinite Loop, Cupertino, California, with a title of Apple and a subtitle of One Infinite Loop. And that's pretty much the basics of the MapKit framework. So if you want to go further, one of the things I do recommend is you check out the location SDKs by Skyhook Wireless, the guys that do the Wi-Fi positioning for all the iPhone devices, and also the location SDKs for Simple Geo. I do cover a bunch more of this material in my own book, Learning iPhone Programming iPhone Sensors. And if you use the ABF10 discount code, you'll get some discounts off that, although not as good as the Webcast one, which I didn't know about beforehand, so that's a good discount code. I also cover a whole bunch of this stuff in the O'Reilly Masterclass, which earlier, and you can get a discount off that again. Or O'Reilly's running a cool promotion, which is buy one, get one free right now. So there you go. I talk about computer vision, augmented reality, and a whole bunch of sensor related. So that's just a brief overview of CoreLocation and MapKit. So what we're going to do now is going to break out of Keynote, and we're actually going to go into Xcode. And I'm going to sit down, and we're going to live code MapKit and CoreLocation based application. So here we go. So let's start up Xcode. And we're going to create a new Xcode project. And we're going to choose a view-based application for the iPhone. And we're going to call it Where Am I? We're going to save it to the desktop. Okay, so let's just resize my window here. And expand groups. Yeah, I just saw a question pop up in the corner, and yes, the masterclass is on Safari Online. Okay, so the first thing I need to do is add the CoreLocation and MapKit frameworks. So if we click on the frameworks group, and then add existing frameworks, and add the CoreLocation, then add existing frameworks, and add the MapKit framework there. Now, I could include the header files for these two frameworks for each of my classes, but instead I'm actually going to go to the prefix header file and import the headers here, which the prefix header file is actually prepended to all of our classes. So that's going to save us some typing. And just save that. Okay, hopefully this font's big enough for everyone, but you're actually going to be able to download this the source code from my website later on. So don't worry if you're going to catch the gist. So let's go to the Where Am I view controller, and let's start off by editing the interface file. So we're going to need an MK map view, call it map view, and a couple of UI labels, probably latitude, longitude. And we're going to declare those as properties. And ID outlets. Copy and paste here. Okay, and moving to the corresponding implementation files. We're actually going to go ahead and clean this up a bit and remove some of the code and insert a bit of default Xcode template, because we're not going to be using it. what we need to do is synthesize our properties. And then since we've retained them, we, of course, have to release them in the Delegate method. Okay, so that's all we need to do to the view controller for now. So let's just grab the view controller's nib file and jump into Interface Builder. So let's grab a map view from the library window and drag it into the view window. Then we're going to click on Files Owner and connect that up to the outlet we created in the view controller. Now we're just going to grab a round rectangular button, which is just an easy way to get a nice white box that we're going to put things on top of, and drag it down into the bottom right-hand corner there. Let's turn off, make that turn off user interaction enabled, because we don't actually want the user to be able to click on that. So let's then grab a label and drag that into on top of our UI button. We'll call that latitude. Copy and paste. Longitude. There we go. And then we're going to just grab two more UI labels. And drag that there. That's 0.0, 0. And then we're going to click on Files Owner, Connections panel, and connect the latitude to that label and the longitude to that label. And then we're going to save and return to Xcode. Now we're actually going to do most of the heavy lifting inside the app delegate. So let's grab the app delegate interface file, and we're going to declare this as a CL location manager delegate. And we're going to add CL location manager called location manager. And we're going to declare that as a property. So then in the corresponding implementation file, we're just going to go ahead and synthesize our property. And in the application did finish launching with options method, I'm going to grab a reference to our location manager. And set it to auto release. Now we're just going to do a quick if statement to check CL location manager location services enabled. Now this actually changed between iOS 3 and iOS 4 from an object property check to a class method. I think I may actually have used the deprecated object property in the slides, but either is going to work. So self location manager delegate equals self. So we're going to set the delegate for this our location manager instance to this current class. Self location manager distance filter going to set that to 100, so that's going to be in meters. And then self location manager start updating location. So if location service is enabled, then we're going to send delegate messages to the current class. So our distance filtered to 100 meters. So changes in location under that won't be generated delegate method. And then we're going to start generating those delegate methods. Okay, so the only thing left to actually do is implement our delegate methods. So if we scroll down the bottom here and we put in a pragma mark, for location manager delegate methods. Now, for those of you that aren't familiar with pragma marks, it's actually quite a cool feature in Xcode that let you jump between pragma marks here. Just an easy way if the class gets large to manage your methods. Okay, so an easy way to get to know what your actual available delegate methods are is to alt-click on the CL Location Manager delegate string there, and that'll take you directly to the developer documentation. So we're going to implement the location manager did update method and the location manager did fail with error method. So let's just click on that and actually grab the directly from there. It's a long method name, and I've mistyped it on more than one occasion. So now I generally just go directly to the developer documentation and grab it from there. Going to quickly save and build, see if we have any errors at this point. We have quite a lot, so that's a fairly obvious error. I should have done it, and the build succeeded. Let's go ahead and implement those delegate method. So in Location Manager did update to location from location. I'm actually going to grab an MK coordinate span, and I'm going to make this span.latitude delta equal 1 degree. And the longitude delta equal about 1 degree. And then I'm going to grab coordinate region, and let's call that region, and set the region span to equal to our MK coordinate span. And the region center equal to our new location coordinate. Then I'm going to take the self view controller, grab an instance to our map view. I'm going to set to be our region. I'm going to make this animated. Then I'm going to make the map view show the current user location. Okay, so what that'll do is it'll take our map view and zoom it into a region about 1 degree around our current location and drop a blue dot in the middle where our device is located. So let's go ahead and populate our two UI labels at that point. Self.viewController latitude.text is equal to ns string format float. It's going to be new location dot coordinate latitude. Quite the biggest, so that fits on one line. So we can actually just copy and paste for most of that. I'm going to make that longitude. That longitude. Okay, so we're just going to save that. and get rid of the documentation. We're just doing a quick build. Go. So we hit build and run, and whoops, I'm building for the device. Don't want to do that. Build for the simulator. So let's build and run in the simulator. Now, as I mentioned earlier on during the slide portion of the talk, the simulator is actually going to prompt us to whether we can use the current location. So I'm going to say yes to that. And as you can see, it zooms somewhere just north of Exeter, which is in the southwest of England. Now, this actually shows up two irritating bugs in the MapKit, which weren't present before the 4.0 SDK. Now, while we're zoomed into my current location in the southwest of England okay, and CoreLocation therefore has geolocated me correctly, MapKit hasn't. MapKit isn't in the simulator when it's running in the simulator, isn't paying any attention to the actual user position, and in the simulator only still returns the default position for Cupertino, California. And we can actually show this by zooming out. Just going to zoom out. And there you go. The blue dot, which should be over my current position, is dropped into Cupertino, California. And it doesn't actually seem to be an easy workaround for this bug, other than to implement a mock CL location manager class and actually filter your locations through that. Now, the second bug in MapKit can actually be seen in the debugger console over here. Now, this is another post 4.0 SDK MapKit error, and is in the map view from annotation method. Now, you can override this method to display a custom annotation for the user's location, or if you return nil from this method or just don't implement it at all, the default annotation is used, which is that blue dot you can see over here. Now, unfortunately, if you don't override this method, or if you return nil from this method to use the default annotation, this warning is going to be displayed in the debugger console, and it's going to trigger every time you show the user location in MapKit. Don't worry about it. It's not critical. You can just ignore it. But that's two irritating bugs in MapKit. Now, returning to our first bug, I mentioned you can actually create a mock CL location manager class and override the location provided by location manager in the simulator. Now, Jonathan Dalrymple has actually done a nice implementation of this, and you can grab it from his GitHub archive. And this is CL location manager mock object. So what I'm actually going to do is I'm actually going to show you how that works. So here's one I made earlier. Just going to grab the from GitHub archive and drop it directly into my application. Then we're going to go again. You can see it's created a timer, it's set the delegate, and any second now it will call, it'll call the delegate method. And it actually is wrapping the CL location manager delegate calls there. This class, of course, isn't needed in a device where everything works as advertising. So if this code was running on your device, the blue dot would appear in the right place. CoreLocation and MapKit would talk to each other all just fine. And so this is pretty cool. We have an application now that will show the user location. It'll scroll with the user location. So for instance, if we move this, it's actually going to snap back to the user's location there. It's the bottom right-hand corner. That's quite nice. But it'd be nice to know if we knew what direction we're facing. One of the problems I have with maps is that I have to start rotating them around to try and figure out what's going on. So let's talk about compasses. And I just saw a question in the bottom right-hand corner there. Yes, the mock location code is available on GitHub. And I'll be posting a link to that on my own website and in these slides. So let's just and copied into the project. And this is just a simple compass rose. I actually made my... let's go to our view controller now. Actually, let's just get rid of our Jonathan code, get rid of the mock stuff. And go to our view controller and just declare a UI image. And we're going to call that compass rose. We're going to declare it as a property. And mark it as an IB outlet. Then in the corresponding implementation, we're going to synthesize that. Of course, release it in the Allan method. Okay, so let's just open our nib file again and drag and drop a UI image view to our nib file. And we're going to square that off at about 120. Okay. So then we're going to add our compass rose image. And then we're going to click on Files Owner, Connections, and connect our compass rose to our UI image view. Then we're going to save and drop back into Xcode. Okay, so back into our delegate. Scroll back our application dish launching with options method. This is actually going to illustrate another bug in the 4.0 SDK, which I only discovered today and had me panicking for a little bit. The correct way that's recommended to figure out whether heading information is available is to call a class method like this. However, if you do that, absolutely nothing will happen. That always returns no. So what you actually have to do is use the deprecated self.locationManager.heading available object property and to figure out whether heading information is available. I haven't actually looked at the 4.2 beta SDK to see if that's been fixed yet, but certainly in the 4.0 and 4.1 SDKs, that is broken, which was quite a scary discovery about 20 minutes before I gave this webcast. So another question, yes, altitude information is available so long as your accuracy is good enough so that you... Okay, so if heading information is available, we're going to use self.location manager, start updating heading. So this means that a whole bunch of different delegate methods are going to be sent to our... So let's scroll down the bottom and implement those delegate methods. So let's go to the document. And you can see responding to heading events, there's actually two delegate methods. Location manager did update heading, and it should display heading calibration panel. Let's just click on that and grab that. This is location manager did update heading. The other one. We're just going to return. Okay, so in the location manager did update heading method, we're going to check if our new heading accuracy is greater than 0. Then we're going to grab the float heading equals minus 1.0 times mpi, new heading, kinetic heading by 180. Basically what's happening is we're getting the heading measured in degrees, changing that into radians. Then we're going to take the self view controller, compass rose. We're going to do a transform on that, and we're going to set that to CG affin transform make station. We're just going to set that heading. What's going to happen here is as the heading update messages come in, we're going to take the current heading of the device. We're actually going to rotate our UI image view so that the compass rose points to the correct heading. So let's just close that down, documentation down, and we're just going to build. And we get a warning for that deprecated method I used to get around the bug in the 4.0. And safely ignore that, at least for now. So let's build and run in the simulator. And you see it zooms in on my current location, and we've got that bug where the map view, and of course our compass rose doesn't actually do anything. That's because the simulator doesn't return a magnetic value heading. Now we can actually get around this again by using another workaround. Now there's actually an application on the App Store from Vimov, which I believe is an Israeli company. I think. Egypt. They're not going to like me calling them an Israeli company at that point. Whoops. So they're based in Egypt, and this is really a cool thing. This is a way to use your device to send multi-touch, accelerometer, GPS, and magnetometer events directly from the device to the simulator. And first of all, need the iSimulate app, which you can buy in the App Store, and then to download their SDK and link it in with your project. So let's go ahead and do that. I already got the iSim on my actual device, and let's just grab the iSimulate SDK, which is just a statically linked file here, a statically linked library, and drop it into our project. The other thing you need to do is just go to your project info window, and in other linker flags, just have to use -object C there. And then we'll just build succeeded, so we're going to build and run in the simulator. You see that this simulator is actually asking whether the Where Am I application should set incoming network connections. This is actually a prompt from my firewall. So I'll hit OK, and you can see here in the debug window, we're publishing a service in this application, and we're waiting for a connected device. So let's just fire up the iSimulator app on my own iPhone. And here we go. So this is actually getting information directly from my iPhone. You see it zoomed in on my current location. And you should be able to see rotating as I move my iPhone around. Hopefully that's clear to everyone. There we go. Just stop iSimulate there. Of course, we still have the same map view problem where we zoom out the current user location is in the wrong place. But on the device, that works just fine. It really is just a simulator problem. And there we go. That's pretty much a Where Am I application that shows you, gets the current user location, scrolls the map to it, zooms in, publishes the latitude and longitude, and shows you the direction you're facing. And I think that's pretty much me for this point. So I'm going to stop sharing my screen and drop into QA.
Hey, Alasdair, what a great demo that was. We have questions over here on the notepad, and I can run through them. And I want to encourage people also to submit your questions now. I'll go back to the ones asked at the beginning. And Alasdair, I think you covered a lot of these, so I'm going to read them to you in case you want to further comment on them. And back at the very beginning,
Cool.
one gentleman asked, I thought the iPhone SDK doesn't use Skyhook anymore. So he asked that in the very beginning.
As far as I'm aware, it still uses Skyhook. Yeah, as far as I'm aware, it still uses
there must
Skyhook.
have been some.
The lookups, I could be wrong.
Okay, and then there were a lot of questions about the magnetometer. I'm not sure how you. Magnetometer.
Well, digital compass.
For instance, does it work in a simulator, and do all iPhones have one of those thingamajiggers? And how can you tell? So which models do?
Okay. The magnetometer does not work in the simulator. I think I covered that during the live code demo. The only iPhones that have the magnetometer are the 3GS and the iPhone 4, and I believe the iPad with the Wi-Fi plus 3G. I'm not sure about the latest generation of iPod Touch. I can't remember off the top of my head. But certainly iPhone models before the 3GS did not have a magnetometer. So the 3G and the original iPhone do not have a magnetometer.
And is there an easy way to tell if it does or doesn't? Or?
Yep. The location manager heading available call will return no if there's no magnetometer on board. That's why I explicitly checked in the code whether the magnetometer was there.
And then one gentleman was asking, why does a magnetometer require GPS?
The magnetometer does not require GPS. The GPS and magnetometer are entirely different. So it just so happens that the Wi-Fi iPad does not have a magnetometer as far as I know.
All right, good. And then and then Michael asked earlier, can you tell us where the documentation for what you're discussing is located, as well as noting what is not in the standard docs. Now I know that a lot of this is covered in your books and in your master class. I think that's what they decided is that some things you were talking about, your master class is probably the best source of documentation. Is that true, or are there other resources?
I do deep dive into this. Yeah, I do deep dive into this in the master class quite extensively. I also build several other demo apps around around this. All of the standard Apple documentation is behind the NDA'd paywall for the iPhone developer site, and pretty much the things that aren't discussed in the standard docs is the bugs I brought up in MapKit, and MapKit itself is fairly poorly documented right now. The annotation stuff, for instance, is very poorly documented. But it's covered in my books and in the master class. So.
Great. And then we have a couple specific questions. Michael wanted to know, can you tell us, oh wait, no, we just answered that. Can your app have more than one reference to a location manager? And then he says, to clarify, in another object view.
I must admit, I haven't tried that in Anger. I see no reason why it shouldn't work. Because you're getting the delegate messages from the instance of the CL location manager. So you should be able to implement multiple delegates. That should work, but I haven't tried it. So yes, I think so, but I wouldn't bet my life on it.
Okay, fair enough. And Michael also asked, how difficult is it to make the map rotate as you move? I would guess for you it's not difficult, but...
It's actually pretty
in general?
trivial. Do we have 5 minutes? I could just do that now.
Sure. Yes, we have that time.
Okay.
Go ahead.
Okay. I'll just share my screen again. Let me know when it comes back up.
It's getting there. There we go. Now we can see it.
We're up. Okie doke. So pretty much the thing you need to do here is self-view control map view. And that's it. So let me just check that, yeah, libsimulate's still there. So if we build and run, allow network connections, connect to the application, and there you go. Basically what you need to do is extend the size of the map view. Can everyone see that it's rotating around? Catherine, can you give me a okay on that?
Oh yeah, it's perfectly clear. That's great. So you'd extend the map so you don't get the gray.
What you just do is extend the size of... Yeah, pretty much. And I can just do that now, in fact. So on nib file. And so currently, let's set that to 500. Run it up in the simulator again. Connection established. Oh, here we go. Okay, so I had to make it slightly bigger than that. It hasn't actually managed to get my CoreLocation. Hang on. I'll just... There we go. So you see, I made it bigger, and the gray bits are smaller now, so you just have to make it bigger again.
That's very nice. Hey, thanks for showing that.
No worries.
Very impressive. I love demos on the fly.
So basically, it's just one more call into the in the method, the delegate method.
Okay. So I think that's all the questions that we have. Any more questions for? Oh. Okay. So Devin is asking. You probably see this. About speed or acceleration data, is that available? Can you see the question?
Yeah, I can see the question. Yes, it is available. It's more easily available from the CoreMotion framework, which I didn't click out, which is the new for iOS 4, and can make use of the gyroscope that's available in the iPhone 4. The speed is theoretically available from CoreLocation itself, and is only really going to be there if the GPS is active. I've not found it to be tremendously reliable, but if you if you go through CoreMotion and you have an iPhone 4 and you use the combination of the accelerometer and the gyroscope, you're actually going to get information about the rotation of the device and the acceleration of the device more easily. So yeah, it's all there, but it's easier if you have the gyroscope enabled, which right now is just in the iPhone 4.
Okay. All right. Well, Alasdair, I can't thank you enough. This was a great webcast, and I know this is a repeat of one that we did last spring, early summer, and it turned out rather disastrous. Not our fault. Yeah, I've tried to put it all behind me. So we had some problems that we had no control over, but this one, very good. So thank you so much for doing it. And yes, we have a recording. We'll have that posted. As soon as we process it, it'll be probably a day or two. We'll try to get on it right away. And we send the link out to everyone who registered. If you didn't register, if you came in as a guest without registering, then you can find it on our webcast page. You can go to O'Reilly.com/webcasts, and usually find it. And Alasdair, what is your website? Where do we go to find out?
I just posted. So
okay.
There's actually several websites. So there's learningiPhoneprogramming.com, and actually the slides from the last outing of this webcast, along with the source code, is available there. I'm going to update the slides, which is all the iOS 4 stuff in it. Possibly not tonight because, hey, I'm in Britain and it's getting late here now. And I want to see my son before he goes to bed. So I'm going to update that probably tomorrow, my time. So I'll also post the link to the video of this webcast on that site when it comes up. There's also code available on the other website, which is programmingiphonesensors.com, which is the website for the next book, which has been somewhat delayed by the arrival of iOS 4.2, was preliminarily scheduled for a December publication in paper, but it's probably going to run a couple of months late now. But that is available in Rough Cuts, so you can get about half the book right now on O'Reilly Rough Cuts and on Safari Online. And if you're interested in various things I do, I also have a blog, which is there. That should come up in chat any second now. I'm getting quite laggy here. And I'm on Twitter at there. So that's pretty much it, I think.
Great. All right, everyone. Well, thank you so much for joining us. We had a great turnout, great crowd today. And Alasdair, thank you again. And I'm just going to give you a couple minutes, and I'm going to close out the chat room, and you'll be hearing from us about the recording. All right, goodbye.